Okay, this video we're going to be talking about multiplying and dividing rational expressions. A rational expression is a quotient of polynomials. Now you can simplify these quotients by factoring, by canceling any common factors in the numerator and denominator, and then simplifying and then writing your restrictions for the domain. What we can also do is we can multiply and divide these expressions. Now it's essentially a four-step process. The first step is to factor completely, factor everything, factor the numerator, factor the denominator, and remember your steps of factoring. The first step is to always factor out the greatest common factor, then check to see if it's a binomial, a trinomial, or four terms, so on and so forth. So make sure you review your factoring. The second step is going to be to divide the numerator and the denominator by any common factors. Essentially, what that's saying is if there's any common factor in the numerator and denominator, you can cancel them. So it's essentially just canceling what you can. Third, the third step depends on whether you're multiplying or you're dividing. So we'll just say multiply or divide. And that's it. And then the fourth, you want to write any restrictions. For the domain. So again, it's a four-step process. Factor, divide or cancel, multiply or divide depending upon your problem, and then list any restrictions for the domain. So let's do a couple multiplication problems. So we'll do multiplication A problem. Let's say we had x minus 7 over x minus 1 times x squared minus 1 over 3x minus 21. So our first step is to factor wherever we can factor. This first quotient here, x minus 7 over x minus 1, there's nothing that we can factor there. So we'll leave that be. In the second fraction, the second quotient here, we have a difference of squares in the numerator. So what we're going to do is we're going to factor that. X plus 1, x minus 1. In the denominator here, we have a common factor of 3, so we're going to factor that out. So that's the first step. We've factored everything that we could factor. Now we're going to see what we can cancel, if we can. So we have a fraction here, we're multiplying it by another fraction. When you're multiplying fractions, once everything is factored, you can cancel vertically within the same fraction, or you can cross-cancel across two different fractions. So what we're going to do is we're going to cancel the x minus 1 there with that x minus 1. So we can cross-cancel. And over here, we're going to cross-cancel the x minus 7 and x minus 7. So what we're left with is the x plus 1 over 3. Now I have to list any restrictions on the variable. So there's no variable down here, but I have to look at all the variables and all the factors in the denominator prior to that step. This will give me a restriction, and so will that. X cannot be 1 because it would cause division by 0 here, and X cannot equal 7 because that would cause a division by 0 there. So that would be the answer for that one. Let's look at another one for multiplying. We'll call this B. Say if we had x plus 3 over x squared minus 4 times x squared minus x minus 6 divided by x squared plus 6x plus 9. Scroll this down. Okay. Let's see if we can factor anything in the first fraction. There's nothing we can factor in the numerator, so let's leave that x plus 3. In the denominator we have a difference of squares. We're going to have x plus 2, x minus 2 times. This over here is a simple trinomial, so we'll factor that. We're going to have x and x, two numbers that multiply to give you -6 but add to +1. So that's going to, add to -1. That's going to be -3 and a +2. Down here what we have is actually a perfect square trinomial. And what that is if you have a perfect square as the first term, a perfect square as the second term, and if you were to take the square roots of those, the square root of x is x, the square root of 9 is 3. If you were to take that product and multiply it by 2, you get the middle term, 6x. Then you know it's a perfect square trinomial. You can also factor perfect square trinomials just like you would a simple trinomial. You'll just notice that you're going to get the same expression times itself, x plus 3 times x plus 3. So we've factored now. Now let's see if we can cancel. Again, look vertically to see if there's anything we can cancel. There's nothing that we can. And then cross canceling. So x minus 3, x plus 3 and x plus 3. We have an x plus 2 and an x plus 2. And that's it. So our numerator is going to be x minus 3 over x minus 2 times x plus 3. For our restrictions, it's obvious that x can't be -3 here. X cannot be +2 there. And it can't be -3. Sorry, that's -3. That's -3. That's +2. -2. That's the other one. So we have three restrictions: +2, -3, and -2. And that is our answer for that one. Alright, so that's essentially what multiplying rational expressions is. You follow the same rules as simplifying rational expressions, and then you multiply the fractions just like you would normal fractions. Alright, let's try a couple division problems. We'll do this as being division A. Let's say if we had x plus 1 over 3 divided by 3x plus 3 over 7. Alright, I guess it would make sense at this point to sort of refresh your memory in regards to how to divide fractions. So when you divide fractions, you take your first fraction and then you're going to change the division sign to a multiplication sign, and then you're going to invert the second fraction. So if it's written horizontally like this, you would invert this second fraction and change the division sign to a multiplication sign. Now there are times when this can be written vertically. You could have x plus 1 over 3, a big division sign, and then 3x plus 3 over 7. In that case, you would leave the top fraction alone. You would multiply by the inverted fraction that you see in the denominator. But this is written horizontally, so let's deal with this. So we could change this to a multiplication sign and invert this before we factor. Or we can factor and then switch the sign and invert. It doesn't make a difference. Let's factor first. So x plus 1 over 3 divided by 3x plus 3. We have a common factor of 3 and the 7 down here. Alright, now let's invert this fraction and change that to a multiplication sign. 3 times x plus 1. Okay, now we treat this exactly like the previous two examples. Let's check to see if we can cross-cancel or cancel vertically within the same fraction. So we have an x plus 1 here and an x plus 1 there. Let's cancel those. You can't cancel the 3 and 3 because that wouldn't be cross-canceling. So what we have is 7 on the top, or in the numerator, and then 3 times 3 is 9 in the denominator. Now in your final simplified answer here, you don't see any variable in the denominator. So what we're going to have to do is just check prior to that every single denominator. Nothing here, 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 but over here we have a restriction. X cannot be negative 1. And that would be it. And when you're writing your answers, make sure that you write your answer here, and then comma, and then any restrictions. And if there's multiple restrictions, separate the individual restrictions by another comma. Alright, let's do another one. Division B. Let's say if we had x squared minus 2x minus 8 divided by x squared minus 9 divided by x minus 4 over x plus 3. Alright, so for this problem, let's start by factoring everything. So over here we have a trinomial. It's a simple trinomial. So this is going to factor as x and x. Two numbers that multiply to give you negative 8, but add up to negative 2. Be negative 4 and positive 2. This is the difference of squares, so we're going to have x plus 3, x minus 3. Now there's nothing to factor over here. So instead of just writing the division sign and then that, and then having to rewrite the entire thing over again, I'm going to change that to a multiplication sign right off the bat and then invert this. Alright. Now let's check to see if we can cancel anything. There's nothing vertically that we can cancel, here or here. So let's cancel diagonally. So x minus 4 and x minus 4, x plus 3 and x plus 3. So our solution, or not our solution, but our simplified answer here is going to be x plus 2 over x minus 3. And for restrictions, we see that x cannot be 3, x can't be 4, and x can't be negative 3. And that would be your answer. Alright, let's do one more. Alright, so the last one, we'll call it C. We have x cubed minus 25x over 4x squared times 2x squared minus 2 over x squared minus 6x plus 5 divided by x squared plus 5x over 7x plus 7. Alright, so let's factor where we can. Up here we have a GCF of x, so we're going to have x squared minus 25. 4x squared is already factored, times. Up here we have a GCF of 2, so we factor that out. Down here we have a trinomial, so we'll put our x's here. This says that the signs are going to be the same and they're both going to be negative. Two numbers that multiply to give you 5, but add to 6, 5 and 1. Divided by, let's factor out an x up here. And down here, let's factor out a 7. Okay, so at this point, you might be wondering why I didn't go directly from division to multiplication. And the reason why is because now that this fraction is factored, this, when x is negative 1, that's going to be part of our restrictions. If you went straight from division here and you inverted this fraction and you wrote it down here, this numerator would be down here, and you wouldn't, well, there's a potential that you wouldn't recognize the fact that this x plus 1 needs to be looked at in terms of a restricted domain. So sometimes it's good writing everything as it is, leaving all the operations alone until after you factor. So let's, we still have more factoring. This is a perfect square trinomial, and so is that. And this time I'll flip. So x times x plus 5x minus 5 divided by 4x squared times 2 times x plus 1x minus 1 over x minus 5 x minus 1 times 7 times x plus 1 over x times x plus 5. Alright, so now let's cancel. We have an x here and an x here. We have an x minus 5 and an x minus 5. X minus 1 over x minus 1. X plus 5, x plus 5. And it looks like, no, that's not it. We have a 2 and a 4. That gives us a 2 here. And that's it. So what I'm going to do is I'm just going to circle everything that we have that's left over. I won't circle, but I'll underline it. We have that, that, that. And then down here we have the 2 and the x squared. So what we have is x plus 1 times 7 times x plus 1 is 7 times x plus 1 squared over 2x squared. Now we have to list our restrictions. So with this answer here, we have x cannot equal 0. Over here we have x cannot equal negative 5. That's x cannot equal 0. We already have that. This is x cannot equal 1. This is x cannot equal 5. That's x cannot equal 0. Let's move up here a little bit. This is x cannot equal negative 1. We don't have that yet. That's positive 1, positive 5, and 0. And we already have those. So this here is our final answer.